guys! Alright, for our last encounter, which is encounter 3, which is the validity of an experiment, okay? This really deals with our standard 1.2, which is to explain why scientific investigations should be replicable, okay? So really what we should focus on is repetition and replication. So let's talk about repetition first, alright? In your repetition, you want to make sure that there's the repeated trials within the same experiment, okay? Repeated trials within the same experiment. We usually do about 3. Why do we do this? We do this to ensure accuracy and precision. And I talked a little bit about this in our encounter 1. Accuracy and precision ensure validity. Key words to help explain why experiments are valid, and why they should be replicable. Furthermore, it's also used to rule out anomalous data. Let's talk about that word. It's a big word. Anomalies, okay, is data that is extraneous to what we're actually capturing. So let's think of an example. So say we're throwing an airplane, okay, a paper airplane, and we throw it, we record, we throw it, we measure the distance, we record, and then all of a sudden we notice there's an air vent, and the air vent has just caught on. And you make the throw, and you see that the airplane that goes into another direction. So once you gather, you don't throw out that data, you keep it, okay? You continue forward, all right? But what happens is whenever you go to graph that data, in other words, the analyzation portion of it, you'll see that you are making this graph, and you have all these points, and all of a sudden you have this little sucker that sits right up there by itself, all right? That's considered to be an anomaly. So you don't technically throw it out and discard it and say, I'm not going to talk about this in my experiments. But what you do is you explain that in your conclusion, in your analyzation, your analysis. You say, I can see the error, and the error happened because the air conditioning came on causing draft. So from that point, this impact would cause how did that error impact your experiment at this point? So to rule out anomalous data and to ensure accuracy and precision, we'll make sure that your experiment is valid. So that leads us to the discussion of replication. If you're ensuring accuracy and precision and you're ruling out anomalous data, then other scientists should be able to replicate your experiment. That offers validity, all right? So it's different scientists, keyword different, same for repetition, different for replication, to make sure that they are repeating the same experiment, same variables, holding the same things constant, okay? Now there's a difference between someone investigating and experimenting. Investigatings are done without inference or manipulation. So for example, wonder if Miss Kennedy found a piece of gum underneath her desk, okay? So said person, I'd say, you know what, open your mouth, let me smell that breath of yours. And boy, does it smell minty. Now, the boy at that point, or the girl, could possibly say, Miss Kennedy, I had mint tea at lunch. There you go, all right? So again, just an investigation. Just like you have to figure out, just like what our CSI investigators do, our detectives, our police officers, things like that. An experiment actually has variables. So it actually has a causal effect. So a cause and an effect. In other words, if this, then this, because. So therefore, an experiment must have a hypothesis, okay? So back to our question. Explain why scientific investigations should be replicable. They should be replicable because not only do they ensure accuracy and precision, they rule out anomalous data, they also encourage the lack of bias between scientists, okay? So hopefully that clears up some confusion, and that gives you an opportunity to be able to explain our level 4 of our standard for 1.2, be able to explain why scientific investigations should be replicable. See you soon!